Okie dokester. So, if we're looking at a reminder from last lesson, hopefully, did it save? From last lesson, we were looking at the geometric series, but we've just got a little bit of a question on geometric sequences. So could you turn your page to, well, turn your books to question 21 and 22, and maybe also have your notes open, because we just want to make sure, I'll be honest with you, I'm not a massive fan of these sorts of questions when we're talking about, we looked at the arithmetic mean. And that was pretty straightforward, that we went, yeah, okay, we know the mean, the average. The questions that you had, they just gave you 2, you added them together, divided by 2. If you had 3 terms, you'd add them together and divide by 3, right? Pretty straightforward. So we could write that as T1. So if it was just T1 plus T2, we divide by 2, and that was the sort of questions that you got. But obviously, if there were more, so T1 plus T2 plus T3, we would divide by 3. And the whole point of this topic is to start using notation to help you say generalization of things. So T1 plus T2 plus T3, if I went all the way up to, if I went all the way up to the nth term, what would I have to divide by? N. Correct. So our geometric mean is if we've got the first term times the second term, because now we're talking about geometric and there's a common ratio. So when we times them together, if we've got 2, we then take the square root. If we have 3 terms, if we have 3 terms, then what do? Correct. We take the cube root. And who can predict what I'm going to do next? T1 times T2 times T3 times all the way up to Tn, and we would then take the nth root. Yeah? So if we now have a look at that question, and I'll just pause it a minute, so no blank space. So this is our exercise, was it D, peeps? Yes. Exercise 15D. Again, if you haven't got up to this, you're taking a note, you might just go, oh, I'm going to watch because I know she's going to pop it in our OneNote. So they were just questions that people got up to and went, oh, and we thought, okay, better remind you. So into your notes, these sorts of things go. Not a massive fan of, but anyway. So find the geometric mean. We go easy. We've only got 2 terms, so our geometric mean will be 5 times 720. We square root, and don't think I can do that in my head, but Bowen and I were playing with it yesterday, and we know that it's 60. Right? So is it something that's going to come naturally to you? Probably not. You need to make sure that we are remembering ratio times square root. Are we happy with that? With this one, I like that. What are we doing there? Once again, we're going to times them together and square root. So square root x squared y cubed times x to the 6 y to the 11. Some of you people with your writing, I don't think your teachers have hammered you enough, because situation like that, make sure your x's look different to your multiplication. Some of your penmanship is beautiful, but it's so you don't make a mistake, okay? What happens here? So we've got timesing by the same base, we add the powers. 11 plus 3 is 14, and how are we meant to take the square root of that? Do you remember? Pardon? It might help if I remind you that we can also express the square root as to the power of 1/2. Correct. So when we have got a power to a power, we times them. So it would actually end up being, oops, didn't mean to do that, x to the 4, oh, something's going on, x to the 4, y to the 7. We're good with that? Okay. Can we just have a show of hands? Who's tried 22? Oh, that's technically one. 20. We're feeling 22. So just for a minute, all right, we'll go. I'll start the minute when I stop talking. What I want people to do is go, well, what can you put down? What's the minimum amount or maximum amount? Sorry, not minimum. Maximum amount that you could write down from what you are reading there. Okay, and it has to be something. I do not want, I can't say blank space again, but I do not want blank piece of paper. Imagine that you're having the best day of your life and have a go at this question. So we could leave you suffering for quite some time. I can see some of the frowny faces, which means we're thinking, and that's good. But here we go. 4th, 7th, and 16th terms of an arithmetic sequence also form consecutive terms of a geometric sequence. I go, The only thing that I can think of at the moment is to go, well, T4, if I'm putting that into my Tn equals A plus N take 1 times D, I could say that's A plus 4D. Would you agree? 3D. I knew that. Who's 3D? 2D. Sorry about that. And then while I'm doing that, I might as well do the same for the 7th. That would be A plus 6D. And while we're here, might as well just do them all. 16th term. Oh, I'm predicting 16th. So that will be A plus. So we've probably got as much as we possibly can out of the fact that they're arithmetic. Then we move on and we go, okay, they are consecutive terms of a geometric sequence. Now, what does that mean for us if we've got consecutive terms of a geo? Yeah, Keats?
That they're like, they're in order. Like...
Yep, they're in order. And when we're talking geometric, what does that mean without order? They would have the same. You just said that divided, yep, which means they have the same ratio. So if I wanted to go the ratio, now we did a question similar like this with arithmetic means with the K's from Hazy, remember? And if you haven't, make sure you do it. It was in your assignment as well. So we've got, would you agree, A plus 6D over A plus 3D equals, you finished? Yep. Rian, have you done this? Pardon? Oh, sorry. It didn't look like your eyes were glued this way. Seemed to be out the window, but that's okay. My mistake. So this is what I was playing with, and then I thought, oh, that's a bit mean because there's a lot of unknowns in here. But great example for, well, do you know what? Just go until you can do no more. So one of the things that I want to do, I mean, what do you think? Want to try and expand, like get rid of the fractions? So we are going to cross multiply the suckers. Like if I could find a value for A and a value for D and pop it back in, that would be fantastic. I'm a little bit apprehensive. I don't know if I can because I need 2 equations when I've got 2 unknowns and I've really only got 1 equation. But let's just see what happens. So A plus 6D squared equals expand, please. So we expanded Happy? I'm not going to ask who did, but I'm sure someone might have gone a squared plus just 36d squared. So just remember, when you're expanding a perfect square, do it properly. Don't forget that middle term. 2 times both bits. Anyway, what do you notice? What do you notice? What do you see? A squared? A squared? So a little bit of high hopes there. Can we do anything else? What I'm going to ask you to do is, can you somehow get an expression for A? So get A equals, and then what we're going to do is I can sub that back into, and I should be able to get a ratio, because I'm going to have an expression for A in terms of D, and then you can pop it back in here and see what ratio we get. Give it a go. So we're going to sub that back in, back up here, because the issue that we had with that ratio was that we had an A and a D, and that was no good. But now what we can do, and I'll just do it over here, we've got A plus 6D all over A plus 3D. So we're now going to replace this A with this fraction. You might be going, are you serious? Why on earth would you do that? Well, just look what happens on the top line. Minus 3 over 2D plus 6D. Can't I just pull out the D as a common factor? And I'd be able to do the same on the denominator. So what actually happens is all these D's cancel out, because I'm technically pulling it out as a common factor. We right, Zach? Not Zach. Not Zach. Zach was over here. So do you need me to write it nicely, pulling out a common factor? Just so you don't think I'm just doing a D upstairs and a D downstairs. So now the D's cancel, and I'm left with whatever that is. Whack it in your calculator. What do we get? Minus 1.5 plus 6. So 3. Now, the point of that, my friends. What don't you get? The point of that was, don't give up. Keep persisting, and that is hard. That's the hardest question you'll ever get. Will you ever have to do it by your good selves? I don't think so. Okay? So, that was the geometric sequences. As soon as they start saying, let's add up our geometric terms, Joe, as soon as they start saying, add up your geometric terms, then we're looking at our formula here. Who can remind me what we were talking about with this formula? Right, the infinity for when your ratio is between 1 and minus 1, it will converge if it just keeps on going and going and going. Okay? So don't try and use one of these, use this. Are you happy now that you can just work through these questions and I will be quiet and just come around? Or are there major issues? I will get back to the other page. Yes? So we're going through from the schedule, finishing off. I would like to have switched now to Hazy, but we do not have the subscriptions yet, so you will be able to do some of those revision questions on Monday. They've got some great reviews. Hope you had a hoot at the concert, Charlotte, if you're listening to this, and enjoyed Taylor Swift. All right, see ya.